Holocene has ended. What we do now and in the next few years will profoundly affect the next few thousand years. The only conditions modern humans have ever known so far are changing, and changing fast.
Nothing stays the same on this planet. Everything changes.
Welcome to the infinite expanse of space. A place so vast that even light, the fastest thing in the universe, takes billions of years to cross it. Let's explore the wonders of our cosmos, from the planets of our solar system to the mysteries of distant galaxies. Our journey begins at the heart of our solar system, the Sun. It's a giant ball of gas made mostly of hydrogen and helium, producing energy through nuclear fusion. Every second, the Sun releases more energy than humanity has used in its entire existence. Mercury, the closest planet to the Sun, is a world of extremes where temperatures swing from boiling hot during the day to freezing cold at night. Next is Venus, often called Earth's twin because of its size, but its thick atmosphere traps heat, making it the hottest planet in our solar system. Earth, our home, is the only planet we know that supports life. Its perfect distance from the Sun creates the right conditions for liquid water. And then there's Mars, the red planet, with its dusty landscapes and the largest volcano in the solar system, Olympus Moon, Mons. Beyond Mars lies the asteroid belt, a region filled with rocky debris. Then we reach the outer planets. Jupiter, the last planet, could fit over 1,300 Earths inside it. Its great red spot is a massive storm that has been raging for centuries. Saturn, famous for its stunning rings made of ice and rock, is so light it could float in water. Uranus, tipped on its side, has an unusual rotation, and its atmosphere gives it a striking blue-green color. Finally, Neptune, the farthest planet, has winds that reach speeds of over 2,000 kilometers per hour, the fastest in the solar system. Pluto, once considered the ninth planet, is now classified as a dwarf planet. It's part of the Kuiper Belt, a region filled with icy bodies. Beyond this lies the Oort cloud, a theoretical shell of cosmos surrounding our solar system. Our solar system is just one of the billions in the Milky Way, a barred spiral galaxy that spans 100,000 light years across. It's home to stars, nebulae, and black holes. The closest star to us, Proxima Centauri, is over 4 light years away. If you traveled there at the speed of light, it would take you 4 years. Beyond our galaxy, there are trillions more. Some, like Andromeda Galaxy, are so massive that they're on a collision course with the Milky Way. Others are tiny and faint, barely visible with even our most powerful telescopes. Black holes. Regions of space where gravity is so strong that not even light can escape. Challenge our understanding of physics. And then there's the neutron stars, incredibly dense remnants of massive stars, where a sugar cube ice piece would weigh billions of tons. The universe is still full of mysteries. Quasars, powered by supermassive black holes, shine brighter than entire galaxies. The cosmic microwave background, a faint glow of radiation, is a relic from the Big Bang, offering clues about the origins of everything we see. Let's go into one of the most amazing and interesting things in space: black holes. Black holes are regions in space where gravity is so strong that nothing, not even light, can escape. These cosmic phenomena are among the most mysterious and fascinating objects in the universe. They form when massive stars exhaust their nuclear fuel and collapse under their own gravity, creating a gravitational pull so intense that it warps the fabric of space and time itself. Here's a detailed breakdown of their key features. Number 1. Event horizon. The event horizon is the point of no return. Surrounding a black hole, it marks the boundary where the gravitational pull becomes so overwhelming that nothing, not even light, can escape its grasp. The closer an object gets to the event horizon, the stronger the gravitational forces become. Once something crosses this boundary, it is inevitably pulled into the black hole. Singularity. At the core of a black hole lies the singularity, a point where matter is compressed to infinite density and space-time curvature becomes infinite. The singularity defies our current understanding of physics, as the laws governing quantum mechanics and general relativity break down under these extreme conditions. Scientists continue to study singularities to unravel the mysteries of black holes and the fundamental nature of its universe. Let's go over the types of black holes and what they all mean. Number 1. Stellar black holes. These form from the remnants of massive stars after they undergo a supernova explosion. They typically range from a few several tens of times of the mass of the Sun. Next, supermassive black holes. Found at the centers of galaxies. These giants have masses ranging from billions of millions of times of that Sun. The supermassive black hole at the heart of our Milky Way, Sagittarius A, has a mass equivalent to about 4 million suns. Intermediate black holes. These are rare and less understood type. With masses between those of stellar and supermassive black holes, they may form from the merging of smaller black holes or from the collapse of massive star clusters. Primordial black holes. Hypothetical black holes that might have formed shortly after the Big Bang due to high density fluctuations in the early universe. These black holes could range in size from subatomic scales to several times the mass of the Sun. Accretion disk. When matter, such as gas and dust, falls toward a black hole, it forms an accretion disk, a spinning disk of superheated material. As this matter spirals inward, friction and gravitational forces heat it up to extreme temperatures, causing it to emit energy and light across various wavelengths. The intense radiation from an accretion disk makes black holes detectable, even though the black holes themselves are invisible, which makes them 10 times more scarier. Effects of black holes. Space-time warping. Black holes warp the fabric of space and time, creating gravitational wells that affect the orbits of nearby objects. This phenomenon is described by Einstein's theory of general relativity. Spaghettification. Objects approaching a black hole experience extreme tidal forces. The side closer to the black hole is pulled more strongly than the opposite side, stretching the object into a long, thin shape, a process known as spaghettification. Gravitational waves. When black holes merge, they release massive amounts of energy in the form of gravitational waves, ripples in the fabric of space and time. These waves were first detected in 2015, providing a new way to study cosmic events. Discovery and research. The first black hole was identified was Cygnus X1. Discovered in 1964, it was detected due to the X-rays emitted by its accretion disk. In 2019, the Event Horizon Telescope, EHT, captured the first ever image of a black hole shadow in the galaxy M87, about 55 million light years away. This groundbreaking achievement provided direct visual evidence of black holes and validated decades of theoretical predictions. Ongoing research with telescopes like the James Webb Space Telescope and observations such as LIGO and Virgo continues to uncover new insights about black holes, their behavior and their impact on the cosmos. Black holes are not just destructive entities, they play a crucial role in shaping galaxies, driving star formation and influencing the dynamics of the universe. They challenge our understanding of physics and inspire endless curiosity about the unknown. As we study them further, black holes may hold the key to unlocking some of the greatest mysteries of the cosmos. Now, let's talk about two of the most amazing and crucial parts of human exploration in space. The journey of human space exploration is marked by pivotal events that have expanded our understanding of the cosmos. Two such milestones are the first successful launch of a liquid-fueled rocket by Dr. Robert H. Goddard in 1926 and the historic Apollo 11 moon landing in 1969. Let's delve into the details of these groundbreaking achievements. On March 16, 1926, in Auburn, Massachusetts, Dr. Robert H. Goddard launched the first liquid-fueled rocket. This event is often considered as significant as the Wright brothers' first flight. Goddard's rocket, standing about 10 feet tall, utilized gasoline and liquid oxygen as propellants. Upon ignition, the rocket ascended to an altitude of 41 feet and landed 184 feet away after a 2.5 second flight. This modest flight demonstrated the potential of liquid-fueled rockets, laying the foundation for modern rocketry. Fast forward to July 16, 1969, when NASA launched the Apollo 11 mission from the Kennedy Space Center in Florida. The crew comprised Commander Neil Armstrong, Commander Mole Pilot Michael Collins, and Lunar Module Pilot Edwin Buzz Aldrin. Their objective was to perform a crewed lunar landing and return safely to Earth, fulfilling President John F. Kennedy's goals set in 1961. The spacecraft consisted of Saturn V launch vehicle and the Apollo spacecraft, which included the Command Module Columba and the Lunar Module Eagle. After a 4-day journey, Apollo 11 entered lunar orbit on July 19, 1969. The crew conducted system checks and prepared for the lunar landing. On July 20, 1969, Armstrong and Aldrin boarded the Lunar Module Eagle and began their descent to the moon's surface. Despite navigational challenges and alarms from the guidance computer, Armstrong manually piloted the module to a safe landing spot. At 2017 UTC, Armstrong radioed the Houston Tranquility Base. Here, the Eagle has landed. The landing site, named Tranquility Base, was located in the moon's Sea of Tranquility. First steps on the moon. Nearly 6 hours after landing, on July 21, 1969, at 2:56 UTC, Armstrong descended the lunar module ladder and set foot on the moon, uttering the iconic words, "That's one small step for man, one giant leap for mankind." Aldrin joined him shortly after. The two astronauts spent approximately 21.5 hours on the lunar surface, including a 2.5-hour lunar walk, during which they collected samples, deployed scientific instruments, and documented their activities. Return to Earth. After their lunar activities, Armstrong and Aldrin lifted off the lunar module's ascent stage to rendezvous with Colin in the command module, Columba. The crew then began their return journey to Earth, safely splashing down the Pacific Ocean on July 24, 1969. The mission not only achieved its primary goal, but also paved the way for subsequent lunar explorations. Significance. These two events, Goddard's pioneering rocket launch and the Apollo 11 moon landing, represented monumental steps in space exploration. Goddard's work provided with the technological foundation for rocketry, while Apollo 11 showcased human ingenuity and the ability to overcome formidable challenges, inspiring generations to continue exploring the unknown. One of the most enigmatic objects in space is the black hole. Formed from the collapse of massive stars, black holes are regions where gravity is so strong that not even light can escape. At the center of most galaxies, including ours, lies a supermassive black hole. The one at the heart of the Milky Way, Sagittarius A, has the mass equivalent to 4 million suns. Recent breakthroughs like the Event Horizon telescope's images of a black hole gives us glimpses into these cosmic monsters. Black holes may seem destructive, but space is also a birthplace. Nebula, vast clouds of gas and dust, are stellar nurseries. Stars ignite within them, lighting up the universe. The Orion Nebula, for example, is a brilliant nearby region where stars are being born. These nebulae also contain the building blocks for planets and possibly life. Speaking of planets, astronomers have discovered over 5,000 exoplanets orbiting stars outside of our solar system. These worlds vary widely. Gas giants, icy worlds, and rocky Earth-like planets. The search for life focuses on planets within the habitable zone, where liquid water could exist. One exciting candidate is Proxima Centauri b, just 4.2 light years away, orbiting the closest star to our Sun. Could life exist beyond Earth? It's a question that drives much of our exploration. Scientists study extreme extromphios, organisms thriving in extreme conditions on Earth. To imagine what alien life might look like, oceans beneath the icy crust of the moons like Europa and Enceladus could harbour microbial life, while the methane-rich atmosphere of Titan hints at unique chemistry. Our quest to understand space relies on technology. The James Webb Space Telescope, launched in 2021, peers deep into the universe, capturing light from the earliest galaxies. Space missions like Voyager 1 and 2, now in interstellar space, continue sending data decades after their launch. The Perseverance rover on Mars and the Artemis program efforts to return humans to the moon pave the way for future exploration. What about travelling to other stars? Interstellar travel remains a distant dream, but concepts like warp drives and solar sails spark imagination. The Breakthrough Starshot initiative aims to send tiny spacecraft to the Alpha Centauri system within a human lifetime, propelled by powerful lasers. Our universe is expanding, and its growth is accelerating, driven by a mysterious force called dark energy. Dark matter, another puzzling component, makes up about 27% of the universe's mass and energy. Together, dark matter and dark energy shape galaxies and cosmic structures, yet their nature remains unknown. The universe began 13.8 billion years ago with the Big Bang, a moment of immense energy and expansion. Since then, stars and galaxies have formed, evolved, and died, creating the elements we see today. Our understanding of this timeline comes from studying cosmic microwave background radiation, the faint afterglow of the Big Bang. Despite its vastness, space reminds us of how small but significant place in the cosmos. The search for answers drives collaboration and innovation, uniting humanity in curiosity and wonder. As we continue to explore, who knows what we'll discover. The universe is a story still being written, and every day discovery brings us closer to understanding our place in the grand cosmic tapestry. In the end, space reminds us of how small we are, yet how limitless our curiosity can be. As we look to the stars, we're not just exploring the universe, we're exploring what it means to be human.